Okay, this is a video that's just going over what you had for homework over the weekend, okay? So question number 1, it wants you to rearrange for v. So 1a, to get v by itself, just divide both sides by t. And you're left with v equals d over t. For b, to get v by itself, you need to multiply both sides by v first. So it'll become vt equals d, and then divide both sides by t. And again, you'll be left with v equals d over t, just like you were over here. The next one, get v by itself, multiply both sides by 2d, and so you end up with v squared is equal to 2ad or 2dA, and then take the square root of both sides. So plus or minus square root of 2ad. And the last one, to get v alone, multiply both sides by a. And so you'll end up with v is equal to ab over c. All right, number 1, done. Number 2, exactly the same idea. It just wants you to rearrange for E this time. E is for energy. So to get E by itself, for the first one, multiply both sides by S. And you'll be left with E equals Fs. For B, to get E by itself, first multiply by V squared. So you'll end up with 2E is equal to mv squared, and now divide by 2. And so you will get E equals 1/2 mv squared, or mv squared over 2. We tend to write it as 1/2 mv squared because it's actually the equation for kinetic energy that you'll see in a month or so. But it's the same thing as mv squared over 2. And for C, multiply both sides by c squared. E equals mc squared. Some of you might recognize that as Einstein's famous energy mass equation. For number 3, we want to get D alone. So we actually did this one on Friday. Subtract v squared from both, or vi squared from both sides. So you'll have v squared minus vi squared equals 2ad, and now divide both sides by 2a. And so you'll have d is equal to v squared minus vi squared over 2a. Okay? Next one, I want you to write it in scientific notation. And remember, when you're writing in scientific notation, you keep the correct number as sig figs. So these 3 zeros in this guy do not count, so we don't keep them. Number in front of the decimal needs to be between 1 and 9, so we put it here after the 6. So it becomes 6.03 times 10 to the 1, 2, 3, 4. We moved it 5 places. Positive meters. Keep your units. This one, we're going to move it over here after the 6, so it'll be 6.4. Those leading zeros do not count. 6.4 times 10 to the negative 4, and again, meters. This one, these trailing zeros don't count. Number goes after the 7, so 7.83 times 10 to the 5th grams. This one, decimal is going to go after the 1, so 1.8 times 10 to the negative 2, and again the leading zeros don't count, centimeters. Number 5 just wants sig figs, so zeros after a decimal count, so all of these guys count, should be 6. Zeros when there's no decimals, trailing zeros do not count, so this one's only going to have 4. Trailing zeros after the decimal do count, this one will have 5. Leading zeros don't count, zeros after the decimal do, 4. Oh, now I have a decimal, so this looks like B, but with a decimal, that in zero is going to count 5. Digits in the scientific notation don't count, just these 3 do, so this will be 3. Trailing 0 doesn't count, 5. Trailing 0 after the decimal does count, 3. Trailing 0 after the decimal does count, so they all count, 7. And this one looks an awful lot like B. I must have dozed off and not noticed it was the same question. It'll have 4. Okay, next sheet wants you to add these guys together. or do the math operations in number 6, and then come up with how many sig figs. So for the first one, when you add them together, you get 14.106. How many significant digits am I allowed to have? Well, actually in adding, it's the number of decimal places. This guy only has 1, this one has 2, this one has 3. Keep the least number, I can only keep 1. This becomes 14.1. So it's number of decimal places. Multiplying, though, it is number of significant digits. This, when you multiply them together, will be 28.6578. This guy has 3 sig figs, this one has 4, so I'm only allowed to keep 3. So 3 will be 28.1 more, and I have to round it up because of the number after it, so 28.7. Dividing is the same as multiplying, so when you do this out, you get 8.017647, etc. But I'm only allowed to keep 2. That one has 4, this one only has 2, so 2 would be 8.0. Done. All right, last question, converting. So conversion factors, please. I want to get rid of meters, it goes on the bottom. I want to end up with kilometers, it goes on the top. There are 1,000 meters in 1 kilometer, so I'm dividing by 1,000, and I'm getting 0.0039 kilometers. This time I'm changing from kilometers to meters, get rid of the kilometers, so it goes on the bottom. End up with meters, it goes on the top, so I'm multiplying by 1,000, 8600 meters. This time I'm going from millimeters to kilometers, so you might want to do 2 conversion factors. First one to get rid of the millimeters and change into meters, so 1 in 1,000. And the second one to get rid of the meters and end up with kilometers, and again 1 in 1,000. I am absolutely fine if you do this all in one step, but if you're not sure how many millimeters in a kilometer, this will work because hopefully you know it's 1,000 in 1,000. So in the end, you divide by 1 times 10 to the 6th, or a million, and you should end up with 3.28 times 10 to the negative 5 kilometers. And if you wanted to write that with a whole bunch of zeros, which is painful, 0.0000328 kilometers. Scientific notation is so much easier. All right, kilometers per hour to meters per second. 2 conversion factors. First one to get rid of the kilometers, it goes on the bottom, meters on the top, 1,000 meters, 1 kilometer. Second one to get rid of the hours, it's on the bottom, so you have to put hours on the top in your factor. Seconds need to end up on the bottom, so they go on the bottom in your factor. 3,600 seconds, 1 hour. So multiply by 1,000, divide by 3,600, and when you do, you end up getting 22.7 repeating. All right, and the last one. This time getting rid of meters, so it goes on the bottom. Kilometers goes on the top, 1 kilometer, 1,000 meters. Getting rid of seconds, which is on the bottom, so it goes on the top. You want to end up with hours on the bottom, 3,600 seconds, 1 hour. So multiply by 3,600, divide by 1,000, you should end up with 79.2. So for those of you that are still working on that conversion sheet, these are the conversion factors you have to have if you want to get all the points when I'm asking you to show me how you're converting. Okay, I will probably do another video just to talk about vectors a little bit. Please work on the back side of this math sheet because it's going to be due on Wednesday. Have a good day. Thanks.